Hello and welcome to another tutorial. We're going to continue our learning of Java using ChatGPT. So far we've looked at the Java primitives, and then now we want to look at wrapper classes, the classes that present a type or a object around the primitive types that Java supports. And then for the numeric types, we will look at the autoboxing and unboxing concept that also Java compiler supports. So let's head to ChatGPT and understand what the wrapper classes are. So let's ask, what are the wrapper classes in Java? Now the wrapper classes, again, if you have a primitive type like int, a wrapper class becomes integer class. So in Java, wrapper classes are used to convert primitive data types such as int, boolean, etc. into object. Every primitive type has a corresponding wrapper class. So boolean with capital B, byte, character, short, integer, line, float, double. So again, we have 8 primitive types in Java, and corresponding to that we have 8 wrapper classes. This is useful because certain methods and data structures such as array lists only work with the objects, not with primitive types. And unfortunately, this is one of the limitations of Java when you compare it with a language like C++. Java, the generic types, all the containers, unfortunately, they don't allow primitive types. And I believe at some point, the Java designers realized that this probably would have been a mistake, like this was a mistake, and they're trying to fix this and fixing this problem so that you can instantiate an array list with the int type instead of the boxed integer type. So a primitive type is called an unboxed value, and if you have an integer class, it becomes a boxed value, which means you put a class or object around it. Objects have identity, objects always have overhead. Reading a int value as a primitive type, reading the value of int variable is much faster than reading the value from an integer class. Integer class has a method called get value, something like that. Each of these classes has a corresponding primitive data type, and they provide methods to manipulate the corresponding primitive data. For example, the integer class has a parseInt method that converts a string to an int. So all these wrapper classes, they do have parse methods that they can parse strings and return back a object of that type, right? That converts a string to an int. Actually, the parseInt returns the primitive types. And int value, for example, the integer class, if you want to get the value, you have to call the int value. And all of these, I believe, at least most of them, like the numeric types, they extend a class called number. Number is essentially a class that has all these value methods, int value, double value, etc. And I believe that's an abstract class. All right, here's an example of how you might use a wrapper class. Int i10, we're defining a primitive variable. Integer I wrapper is new integer. And know that the direct use of integer constructor, this new, is deprecated in the most recent versions of the JDK. So calling directly the constructor of wrapper classes is not the recommended way. All you need to do is say integer I wrapper equals 10 or I, right? You just need to put a primitive type here, and the compiler will optimize it away by calling the right method for the wrapper class. And especially for the integer types, some values are already cached when you run JVM. So essentially those objects are already in this integer class as an array of integers, right? I believe it's from -128 to 127. And what happens here is that when you don't directly call the constructor of the integer class, instead you put a primitive value here, the compiler tries to first see if that corresponds to the cache values or not. If yes, it just returns a pointer or reference to that cached value. So let's ask this: what values are cached in the integer class? And you see in this example, all the container types like array list, these are generic types. They never, unfortunately in Java, they don't support primitive types. So you cannot say array list of int. which is very sad. I mean, I wish this would have been possible, and I believe they have ideas to make that possible. But for now, we have to box our primitives. Int becomes integer class, and then you add this. Again, you can define this, but then add a primitive type here. List dot add, for example, 10 or I. And what the compiler does, compiler under the hood converts that primitive value to an integer object, and that's called autoboxing. And then same here, list.get.0, and this returns an integer object inside this list. But then when the compiler sees that you're assigning it to the primitive int, it does auto unboxing, which means you can assign a object of type integer to primitive variable int, and compiler automatically calls the int value method to extract the int value out of it. So that's something that at least they added that to make life much easier. But in general, if the containers could support primitive types, it would have been much easier to deal with these. So in Java programming language, the integer class maintains a cache of integer objects. So it caches objects for values in the range of -128 to 127. That's why instead of directly calling the integer constructor, you should always put a primitive value here. Assign it to an integer object, and the compiler, if it realizes that this value that you're using falls in this range, it uses the cache value. So it automatically optimizes that away. And the way compiler does this, it binds that if you put a primitive here, it binds it to the call to a static method called the value of inside the integer. And in the value of method inside the integer class, it automatically checks if the value is falls in this range. If yes, it returns the cache value. When an integer object is created for a value in this range, the JVM checks the cache to, I mean, it's not the JVM, obviously it's the Java compiler, because this happens at the compile time. Checks the cache to see if an object with the same value already exists. If it does, the JVM returns a reference to the existing object instead of creating a new one. And again, this is optimization that happens in the Java C. Java C is a very dumb compiler, but at least this is very easy to implement, right? So for example, integer I equals 100, integer I2 equals 100. These two objects become exactly the same because Java compiler, when it compiles these two lines of code, returns a reference to the cache values. And then what happens here is that I1 and I2 are just pointing to the same object. That's why when you compare the pointers or the references, these are exactly identical. Now, obviously, you can turn this behavior off. You can also change this range, -128 to 127. If you increase it, then it just consumes more memory, right? So if you put this integer I3 equals 200, integer I4 equals 200, now this 200 falls outside the range of -128 to 127. So the Java compiler still replaced this line with a call to the value of method, the static method inside the integer class, but the value of method realizes that this 200 is not in the cache range, therefore it returns a new object. It just creates a new integer class and returns it. And whenever you create a new object, you call the constructor JVM, always creates a new object, allocates new memory, new object. So these pointers or references are pointing to different locations in the memory. That's why they're not the same. So be very, very careful. Never it's always best to kind of if you have you're comparing integer classes, it's either get the primitive value out of them and compare the primitive values, but I believe the dot equals method obviously still works fine. So it's always best not to compare the references. Use equality with I3 dot equals I4, right? So let's head to Eclipse. And I am going to create a class called, let's say, integer wrapper. And let's have a main method. I would like to show you how this whole works, right? We want to create an integer. Let's call this I1 is 100. All right. and then we want to look at the bytecode to see what happens behind the scenes. And if I go to my navigator, and then if I go to the bin and then open this integer wrapper, open with class. I don't want to decompile the class file. I want just to look at the contents of the class file. Now in the method main, you see that it says invoke static. So by push 100, we push 100 of type integer to the stack of this method and invoke static. So if I put this side by side, you see that this line of code, first obviously this 100 has to be put to the stack, and then we have to create something here. So it says invoke static Java lang integer value of, that takes a primitive int and returns a Java lang integer class. So the compiler binds this. To basically integer dot value of method that takes int and returns an integer class, right? So what happens here is that inside, so this is, it doesn't call the constructor of the integer, because calling the constructor is the instruction or the bytecode is invoke special, and the special method is init, but here we're not calling the constructor. It just calls the value of. So if we go inside, for example, inside the integer class, we look at the value of method, you will see that, or let me see. All right, let's click here, integer class. Let's look for value of method. So value of, this is one version, and I think this is another version. So this is the value of method, a static, right? And then it essentially takes a primitive integer and it's supposed to return a class. And obviously it checks the integer cache first. If this primitive is inside the range of cache, then it just uses this cache, which is an array of objects. Otherwise, it just calls the constructor. And you see that Eclipse shows me that there is a line on the constructor, which means this constructor has been deprecated since JDK 9. However, it's not private or protected anymore. The reason is that obviously backwards compatibility. So the recommended way is always use the equality. If you want to create an integer object, just create it by assigning the primitive integer. The next best thing is to always call the value of method. And again, this line will be translated to the call to the value of. So this is just a syntactic sugar. So this is just a syntactic sugar in terms of simply writing an object equals a primitive. Obviously, this doesn't work in the pure object-oriented sense, but the compiler makes it happen by doing some extra stuff behind the scenes, right? All right, so let's go back to our PowerPoint, and then the concept of autoboxing and auto-unboxing. So let's go to here. Tell me more about autoboxing and auto-unboxing. Again, the autoboxing is this concept. When you say integer object equals a primitive, it boxes it, which means it calls the value of method. In Java, autoboxing is the automatic conversion of a primitive data type to its corresponding wrapper class when it is needed. For example, int I equals 10, and then integer I wrapper equals I. This is autoboxing. Here, the int value 10 is automatically converted to the integer object 10. And again, I want you to really understand the difference between a primitive that has a value 10 and an object that has a value 10, right? Objects have identities. Objects are not the same as primitives. Auto-unboxing is the opposite process, where an object of a wrapper class is automatically converted to its corresponding primitive data type. So integer I wrapper equals new integer, and again, this is not recommended anymore, calling directly the constructor of the integer class. Int I equals I wrapper. What this does, the compiler binds this assignment. First, it binds this to the method int value of this integer class. Autoboxing and autounboxing are useful because they allow you to use primitive data types and objects interchangeably. And this is the great thing. And the reason, otherwise, the life would have been much more difficult using all these numbers with the Java collections, let's say array lists, etc. Because you should always remember to do this kind of things manually, which is tedious. So the compiler takes care of that. For example, you can add an int and an integer together, and the result will be an integer. So int I10, integer I wrapper 20, integer sum is we are adding an object to a primitive. Now, in other programming languages like C++, this is not a big deal. You just realize that, okay, the plus operator is overloaded, right? And even for the user-defined types in C++, you can overload the plus operator. Unfortunately, Java doesn't allow operator overloading. That's why this kind of stuff become not trivial. And in C++, overloading plus operator is trivial for any type. But here they just realize that, okay, it makes sense to overload this operator plus for the integer type. But then for some reason they realize that it doesn't make sense to allow everybody to be able to by default overload the plus operator for any user defined time, which in my opinion it was a mistake. Operator overloading, not allowing that in Java, in my opinion, was a big mistake. However, it is important to be aware that autoboxing and autounboxing can have an impact on performance because they involve the creation of new objects. They can be slower than using primitive data types. This is definitely true. In situations where performance is critical, it may be advisable to use primitives directly rather than relying on autoboxing and autounboxing. What this means is that prefer to use an int array instead of array list of integers. If you are just trying to do some sort of mathematical calculation, because int array is a very flat structure. Array list of integer is not flat. If you don't know what the flatness or the memory layout means, I will discuss this in the future lectures. But for now, what I would like to do, I would like to copy and paste these 3 lines and have a look at the class file to see what happens here. So let's save this. Eclipse automatically compiles it, and then we can open up the class file again with the class file viewer and look at the lines of code. All right, so this is where we create the I1, and then this is where we create the second thing happens. So int I equals 10, we just push an integer I to the stack, which has the value 10. I store 2, we just store it in this integer into the second index or the third index in the stack. Indexes start from 0. And then essentially, and then we pass 2 to the stack, and then we call the value of method, just like we just discussed. And then we store also this object. All right. And then in order to execute this, first we have to load these values into the stack. So I load integer load at the index 2 I. A load means load a reference, not a primitive type, which is I wrapper. And then what happens next is one of these two obviously are different types. This is an integer object type, this is a primitive types. And what happens here is that the way this works, again, this is syntactic sugar. What happens behind the scenes is that the compiler extracts the int value, the primitive value from this class. Invoke virtual means call a non-static method, int value from this I wrapper, right? Invoke virtual, because this method will apply to whatever is, this instruction will be applied to whatever is at the top of the stack, which is a reference to this I wrapper object. And then now we have, and then obviously this is pushed to the stack again. I add means now essentially add the last 2 integers, which is I variable, and now whatever is now was extracted from this int value method. And then after that, now we go back to, we have a primitive result. We go back to something like this. Now the compiler converts this primitive value back to the integer object by calling the static method value of. Invoke static means invoke a static method which is value of, which takes a primitive integer and returns an integer type, and then it pushes that to the stack, but we're not using it, we're not returning it or do anything, so we just return. Now obviously this line of pushing it to the stack can be optimized away, but simply this is always what happens. The result of any calculation has to be the result of an assignment operator has to be pushed to the stack. Now, so again, this is a syntactic sugar. What happens is a compiler takes the iWrapper class and extracts the primitive value by calling the .int value method from it, and then to add two integer int types, right? Which is the I value, which is 10, plus the result of this int value, which is 20. And then 3, convert the int result back to the integer object, right? And we already said that that happens by calling the static method integer.value of, which takes an int and returns an integer. Again, this makes life much easier, and in the world of operator overloading, this is extremely trivial. Like if you tell you don't need to explain this, for example, in C++ programmers, because for them operator overloading is vital. It's very critical. You can't do any C++ programming without any operator overloading. But in Java, because from the beginning they decided to not support operator overloading, this kind of stuff becomes not just trivial or untrivial, which is not good in my opinion. So I hope you really enjoyed this lecture. Please stay tuned, and I'll see you in the next one.